Hello, welcome back to the channel. So let's do one more problem on integration by parts, and in this video we'll derive a new formula which is known as the reduction formula using integration by parts in this case. So whenever you are given an integral in the form of sine to the power nx, something like sine square x, sine cube x, sine to the power 4x, this is the formula that you can use in order to solve for the integral of the expression over there. So whenever you have an integral of the form sine to the power nx, you can always use this formula to make your integral simpler and easily solve your question in these type of cases. And this formula, you don't have to remember this formula, but this formula is also derived using integration by parts, which we will also derive in this video. We'll derive this formula using integration by parts and then see how this left expression is equal to this right expression over here. So let's get started. We have to basically calculate the integral for sine to the power nx, right? So this can be written as, because we want at least two functions over here, we can write this as, since in integration by parts we always assume the second function to what we already know an integral for, right? So we can write sine to the power nx as sine to the power n minus 1x times sine x dx over here, right? Because in this case we have split our sine to the power nx into two parts, and for the second part we already know an integral for, right? Because we already know an integral for sine x, which is minus cos x, so we can easily use integration by parts on this integral over here and calculate the final answer in this case, right? So let's get started with calculating the indefinite integral of this expression using integration by parts in this case, right? So again we'll assume our first function to be sine to the power n minus 1x, the second function to be sine x, and let's do the integration by parts calculation quickly in this case over here. So if we derive this, so let me move this expression to the next page. So again, first function as it is, integration of second, which is minus cos x. So this is the first expression that we got, minus differentiation of first, so differentiation of sine to the power n minus 1x, integration of second, which is again minus cos x, and then integration of this whole expression over here, right? This is the integration by parts formula. So, and if you have any doubts regarding this formula, I would highly suggest you to watch my previous videos where we have covered this concept, the concept of integration by parts, in detail in the last videos. So I would highly suggest you to first watch those videos in order to get the full idea about these videos. So now let's move on to the next step. We will do the rest calculations in this case. It would become sine to the power n minus 1x minus cos x. We can write the whole term as minus sine to the power n minus 1x times cos x. So this minus and this minus over here will become positive, right? So we can write this as positive, and this derivative can be solved using chain rule over here, right? So this would become integral sine to the power n minus 1 times x will, the derivative of that expression will be, the power will come in front. So n minus 1 times sine to the power n minus 2 times x, and because of the chain rule we'll have to also calculate the derivative of sine x over here, right? So this would be, the derivative of sine x is cos x, right? And then we also have a cos x expression over here. So cos x times cos x will become cos square x, and then dx in this case, right? Okay, so now we have this expression over here. Also feel free to comment down in this video if you didn't get this part over here. We basically, in order to calculate the derivative of sine to the power n minus 1x, we basically use the power rule of the derivatives, and then we use the chain rule in order to solve the full derivative of this. So basically the power comes in front, we subtract 1 from the power, so sine to the power n minus 2 times x, and then you'll also have to take the derivative of sine x in this case because of the chain rule. And then because we already had a cos x term over here, so we divided the cos x term which we got from this expression times the cos x term from this expression, so that is why it became cos square x. But feel free to comment down in this video if you still didn't get this part over here. So now let's calculate this one. We can see that this expression is a bit complicated, but if we can convert this cos square x into sine square expression, we can easily simplify this expression over here, right? So let's do that. In order to do that, we also know that sine square x plus cos square x equals 1, right? This identity. So cos square x would simply be 1 minus sine square x in this case, right? And we'll see why we did this step in the next expression over here. So this expression will become simply minus times sine n to the power minus 1x cos x plus this expression over here will become n minus 1 sine n minus 2x. This is 1 minus sine square x dx over here, right? So basically change this cos square x into 1 minus sine square x expression over here, right? So now we can expand this integral over here, right? So this would become simply minus sine n minus 1 x cos x plus, let's split this integral over here. So we'll divide this expression with this term, and then we'll divide this expression with this term, and we'll separate two integrals out, right, in this case. So this would become integral n minus 1 sine n minus 2 x, right, the first expression over here. And in order to calculate the second expression, it would be negative integral n minus 1 sine n minus 2x sine square x dx over here, right? And now if we multiply sine to the power n minus 2x with sine square x, we'll get sine to the power nx, right? And then in this case, we basically got the same expression that we wanted to calculate at the start of the question, right? Which is integral sine to the power nx. And after we solve this expression over here, we'll get a term which would again be similar to the expression sine to the power nx, right? So we'll use the same concept that we used in the previous video. We'll assume the sine to the power nx integral to be I, and then we'll shift this integral, which is on the right side, to the left side, and we'll calculate the final answer in this case. We'll see this process in detail, don't worry about it. So this expression will become sine to the power n minus 1 x cos x plus integral n minus 1 sine n minus 2 times x dx, and this expression over here will become n minus 1 sine to the power nx dx in this case, right? And the left expression over here is also integral sine to the power n dx in this case, right? So if we assume our integral sine to the power nx dx to be I in this case, let's calculate the whole expression over here. We are basically using the same concept that we used in the last video. So if you still didn't get why we assumed our integral to be a new expression over here, I would highly suggest you to first watch my previous video in order to get the full explanation of this concept over here, right? So if we assume this expression to be I, we know that on the left hand side, it's the same expression over here, right? We started with calculating the integral of sine to the power nx dx, right? So this would be I equals, and the other expressions would be same, minus sine n minus 1 x cos x plus integral n minus 1 sine n minus 2 x dx. So these terms will remain the same, right? But this term will be changed to, because this is I, like this whole expression is I, so this can be changed to minus n minus 1 times I in this case, because n minus 1 is a constant, so we can take this constant out from the integral, and by doing that we'll only be left with integral sine to the power nx dx, which we already assumed as I in this case. So now you realize one thing, that we have I on the left side, we also have an expression containing I on the right side, so we can basically shift this expression to this side in order to simplify this integral over here, right? So if we do that, it would basically become n minus 1 times I plus I equals minus sine n minus 1 x cos x plus integral n minus 1 sine n minus 2x dx in this case, right? And the left expression, this expression would become, so this expression over here would become n times I, right? So in order to calculate I in this case, which was the original integral, let's divide both of these expressions by n in this case. So after doing that, we'll have I equals minus 1 by n times sine n minus 1 x cos x plus this n minus 1 is a constant, so we can take this n minus 1 out because we are dividing both sides by n, so we'll divide this expression by n as well, and we will have sine n minus 2 times x dx in this case, right? So this would be our final answer over here. And if you compare this final answer with what we had to prove at the start of the video, this would be similar to this expression over here, right? So you basically have minus 1 by n times sine to the power n minus 1 x cos x, which is this term. And for the second term, you have n minus 1 by n integral. So n minus 1 by n integral sine to the power n minus 2x dx in this case, right? So by following all the basic concepts that we already learned in the previous videos, we have solved this integral over here. We used the integration by parts formula, and then when we use the integration by parts formula, we realized that on the right hand side we got a similar looking expression like the sine to the power n x dx. So that is why we assumed the integral for simplicity to be I, so that we can see the calculations happening on both of the sides. And then by shifting all the I expressions to the left side, we calculated the final integral, which looked something like this over here, right? So that's it for this video. Feel free to comment down in this video if you have any doubts related to this part or any other specific concept in this video as well. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.